Hello, hello, everybody. We are going to start our very first pre-calculus lesson. This is section 1.1 from our textbook. It is modeling and equation solving. So we have a few terms here just so that we are all on the same page. Guys, anytime, this is going to be for all your videos, at any point, if you need to pause the video to write something down, then please do so. Okay, so feel free to pause it, and then you can always go back and rewatch things, all that jazz. So first term we've got here is a numerical model, and that is just talking about numbers or data that are analyzed so that you can gain insights or information into a phenomena or something that's going on. Okay, algebraic model uses formulas to relate variable quantities, and then graphical is what it sounds like. You are graphing. It's a visual representation of numerical or algebraic model. For any set of data, you're able to use all three of these, and all of them are helpful in their own right. So it just kind of depends on the situation and what's going to be the most beneficial for that or what they're asking. Okay. All right, we're going to start off real strong here by doing an example. So I would really encourage you guys to pause the video and write this down, including the table of values, and then start back when you're ready for us to go through it. Okay. So guys, I have this rewritten on another piece of paper because I don't want to write all over my notes here. So I'm going to pull that back up. It's not going to look quite as nice, but it is what it is. All right. So this is me me rewriting that down, and I went ahead and included a little graph. So if you would also like to pause it and write that graph down, that would be fine as well. I've got mine numbered by 5s on the y-axis where it's talking about the distance. And for time, I did not label that, but I probably should. This is just going by ones. So 1, 2, 3, 4, 5, 6, 7, 8, right? So this question says, Galileo spent time rolling balls down an incline and recorded the distance traveled as a function of elapsed time. Give a graphical and algebraic model that fits. So right here, what they've given us is a numerical model. All right, we've got a table of values. All right, they want an algebraic and a graphical. So let's start off with the graphical, since I already went ahead and drew this beautiful little thing. Also, sometimes starting with the graphical one can allow you to get an idea of what type of algebraic model it would be. Because who knows, maybe it's linear, maybe it's quadratic, maybe it's something more. So we're going to start off here just by graphing the values that we have, and then just seeing what that turns out to look like. Okay, so I'm going to start off here. The first table, the first pair is 0, 0, so that is right there at your origin. Then we have 1, 0.75. Now, guys, some of these are just going to have to estimate the best you can. We have 2, 3, so that should be a little bit higher. Then we have 3, 6.75, so that's going to be a little bit above where the 5 is. Okay. Then we have 4, 12. I feel like that does a little bit more of a jump, doesn't it? Maybe a little bit even more higher than that. Okay, 5, 18.75. Ooh, it's going up even more. Maybe up in here. Okay, then we have 627. 627. Down there. Okay, and then we have 736.75. So again, we're just going to eyeball this, make it a little bit more than 35. And then here we have 848. Okay, somewhere around in there. So this is definitely, to me, seeing this, it is not a linear relationship. It is not going in a straight line, right? This is kind of scooping. If you were to connect it all, that to me looks like half of a parabola. That's looking quadratic. All right, so right there, seeing that figure, I can tell that that is not linear. It's probably more quadratic. Now in Algebra 2, you guys did have some ways to be able to determine if something was quadratic or not, or if it was cubic and things like that. You should have had some skills that you learned that with. one thing that you can tell is even looking at this table of values, although the top row is going up by 1 for each step, the bottom row is not going up consistently. For the first jump, it is just 0.75, and then it jumps all the way up to 3, and then up to 6.75. Okay, these are not the same change every single time, so right there, that is not linear. But another way you might have been able to do this in Algebra 2 is you might have looked at the second difference. So although you were able to see that the first difference was 0.75 here, and then on this next one, it would have been 2.25, you would have looked at the difference between those differences. And if you looked at the whole thing, you should see that they're all the same. But that's not necessarily, we're going to get into more of that later on in pre-cal as well. But for right now, what I can tell is even just looking at this graph, it's looking quadratic, okay? It does not look cubic. It does not look like any of those other relationships you guys have studied up to this point. It's looking pretty nice and quadratic. And to me, if this was quadratic, I would be thinking, all right, well, think quadratics are going to have that x squared relationship. Now, this is going through the origin, and that is what a normal quadratic does. If you're thinking of the parent function of a quadratic, it does start, it goes, that little turning point is at the origin like that. So I'm thinking it's probably not been moved up, down, left, or right, or anything. If I was going to write a function, the best way that I could go about it is I could say that right here, this initial value where your x is 1, that would be the number that would go in the front, and then you'd have that x squared. So this guy right here is your initial value at the place where your x was 1. But again, it looks a whole lot like that. Now here's the fun part, okay? We're going to go into our graphing calculator. Now I may need to clear some of this. Ooh, that is not a good look. Didn't test this out much before I put this underneath here. Okay, we're going to try to do some graphing, and I want to see if I can get the brightness down some, see if that makes the screen. Yeah, good. Okay, so we're going to go. This is what it typically looks like when you open up the calculator. You have your calculations, and then you have your grapher. So I'm going to go there to my graphing. Now, this is from something else, so I'm going to clear it really quick. I'm sorry, I should have done this before. Okay, so under the place where they have the expressions for the graphing, we're going to click on Add an Element, okay? And I'm going to go ahead and just bring up the plain old function one right there. It says f of x equals x. I'm going to pull up that one just to get a base. And I'm going to go ahead and pop a squared on here. Okay, the way I've got that is there's this little button right there, x squared. It already had an x on the screen. I hit this, it puts the squared on it. And I'm going to go up to the front, and I'm going to put that 0.75 like I had on my kind of guess right there. Okay, so again, there is your, see if I can get that where you can see it. It's 0.75 x to the second power. Okay, now we're going to go over here to the graph screen and then the table screen, so you can kind of see how they all compare. Right, so the graph screen, you can see what that looks like. Well, our graph was only the right side of this, and that's okay. It's just that right there, right? But I want you to also look at the table of values, and this is really where the moment of truth comes into play, because if these table of values, if these match what we have here, then I know that I picked the right thing, okay? So you can look over here, and I know, remember the top row is my x's, so we're looking along those, and my bottom row is the y's. So we have 0, 0, 1, 0.75, looking good so far. 2, 3, good. 3, 6.75. We have 4, 12. 5, 18.75. 6, 27. This is looking good. Keep going a little bit more. 7, 36.75. Then we have 8, 48. Okay? So that table of values is checking out to match, which means that this is the algebraic representation. We have our graphical one, and we have our algebraic one. Okay? I know that it's a little bit complicated, and it takes some getting used to. It makes you have to remember the things that you did in Algebra 2, okay? So, you know, there's a lot of stuff there. Oh, no. My marker must have bled through this. Oh, well. Okay, so we have another set of notes I want you to get. Now, that guys, this is common sense logic, the zero factor property. What it says is if you have a product of real numbers and that product is zero, that means that one of the factors has to be zero. So if you have something times something equals zero, one of those somethings has to be zero. And we've talked about this before. Anytime we go to solve a quadratic, this type of thing seems to come up. But it's not just quadratics. It is solving many, many different polynomial equations, okay? So we're going to do a couple of examples here where we're going to solve some equations. This first one that you're going to see here, this A, this is 6x to the third equals 11x squared plus 10x. And then B over here, this is x squared equals 10 minus 4x. And I'm going to pull my other piece of paper over here with my examples so I'm not messing up my notes page. Okay? All right. One at a time, guys. One at a time. So you're going to notice that this first equation is a cubic, right? Right there, that is telling me that it's going to have potentially 3 solutions. It doesn't have to have that many, but at most it will have 3 solutions to it. And so we're going to solve for all the real values for x here, okay? All right, so first things first, when I'm solving a problem such as this, in order for me to use the zero factor property, I'm going to need to get everything on the same side of the equal sign so that 0 is all over by itself. Okay, that's your first step. So I'm going to start moving these terms over to the left. Let me get a different color. We're going to subtract 11x squared on both sides. So this is 6x cubed minus 11x squared. We're also going to go ahead and subtract this 10x. So it's all set equal to 0. But what I want you to notice is these 3 terms all have something in common. They all do have an x in them, and I can factor that x out, and that's going to really be the game changer on this problem. So we're going to factor that out. It's going to make 6x squared minus 11x minus 10 equals 0. Now, if there was a constant or a coefficient, if there was a number that I could factor out as well, then I would totally do that. But there are no common factors between 6, 11, and 10 other than the number 1. That means we are going to just continue from here. Now, in order to use the zero factor property, that implies that this thing could potentially be able to factor. Now, that's not a guarantee, okay? But let's try that first. And if we can factor it, then that's going to make our problem a little bit shorter than if you were going to have to try to use a quadratic formula, okay? So let's start off with that. Now I'm going to keep x out here. You can't get rid of him. If you do, you're going to have a problem, okay? So x has got to stay. And we're going to break this apart. And we've got to decide if we're going to factor this thing. You may have a process that you like. That's fine. I'm going to use guess and check, okay? So for this 6x squared, I know that these first terms are each going to have an x in them. I'm going to write in pencil for now, and I'll go back over it in pen once I know what my answer is. But I know that each of these is going to have an x, but I don't know what the coefficients are going to be. So I could either have a 1x and a 6x, or I could have a 2x and a 3x. I don't know. So I'm just going to use my best guess for now. I'm going to go with 2 and 3 just because I think that adds more fun. If it doesn't work, we can always go back and make adjustments, but I'm going to start out there. Now for the last 2, we know that they're going to have to multiply to be 10. So let's try something. I also know that once this is all said and done, the 2 middle terms are going to have to add to make a negative 11. So, here's the deal. When I see this right here, negative 10, and I know the numbers have to multiply to be that, what you guys might be tempted to do is say that they are multiplying to be negative 10, but adding to be a negative 11. And I want to discourage that thought because the first number here is a 6 and not a 1. So that makes the factoring a whole lot harder. You are not simply finding things that multiply to negative 10 and add to negative 11 because this 6 messes that up. So you can't just do it that way. I'm going to pick some numbers that I know are factors of 10. You could do 1 and 10, but again, I probably would look at that and say, well, that's probably not it because 1 and 10, they do add to be negative 11, right? And I want to kind of back away from that. So I'm going to go with something else, maybe 2 and 5. I don't know. Let's see. What if I put a 2 here and a 5 there? Now keep in mind, I do need them to multiply to be a negative 10. So let's put a negative with one of these numbers. I'm going to put it with the larger one just to see if maybe that fixes it. But let's see. If I FOIL this back out, 2x times 3x is 6x squared. We're good there. 2x times a negative 5 is a negative 10x. And I'm writing that very faint. I'm sorry. Try to darken it. Okay, then 2 times 3x, that is a positive 6x. So I'm going to stop right there. Negative 10x and 6x. Does that add to negative 11? No, it does not, which means that is not correct. It's not even close. So it's not like I just need to change the signs. This is not even like it's making a positive 11. Like it's not even a little bit close. So that tells me I need to change more than just signs. I'm going to move the 2 and the 5 and maybe try them in a different location. Let's maybe try the 5 here and the 2 here. I'm thinking I need a negative 11, so I'm going to make the larger number negative and this one positive. Let's just see. 2x times 3x, 6x squared. We're set. 2x times 2, 4x. Negative 5 times 3x, negative 15x. Okay, check. Let's stop. 4x minus 15x. Does that make negative 11? Yes, it does, which means we're set. Now again, check your last times last, just in case you did something funny. Negative 5 times 2 is in fact negative 10, which means this is going to work. I'm going to go back over that in pen, just so that y'all can see that a little bit better. And now we're going to use that zero factor property. So I know that if you have something times something equals 0, one of those somethings is 0. That's just how it works. So I know that either x is 0 or 2x minus 5 is 0 or 3x plus 2 equals 0. And we're going to solve each of those. Now x equals 0, that's already solved. But if I solve this one, we have 2x equals 5, x equals 5 halves. There's a solution. Over here, we have 3x equals negative 2, and then x equals negative 2/3 when we divide. All right, now guys, I want to make the answers really obvious. I have discussed in class, I don't know if I put it in a video yet, but we are going to try not to circle answers as much as we can because in the AP test, sometimes circling your answers can end up hurting you rather than helping you. So rather than circling them, I'm just going to try to make them obvious where I'm putting them. I'm going to say x equals, and then I'm going to list out my little set of what x could be. And I'm going to list them in order from least to greatest. So I'm going to put negative 2/3, then I'm going to put 0, and then I'm going to put 5 halves. Those are the values that x could be. And that's just written in set notation. Okay, guys, we got one more of these questions, okay? This one, hopefully, doesn't seem like it would be as bad because the exponent is smaller, but let's just see. I'm going to use a different color because I don't want these to run together. Let's use this color. Okay. Okay, here we go. Same deal. To solve these, the best interest would be to put all the numbers on one side so that it is equal to 0. So I'm going to have x squared. Then we're going to go ahead and move the x. So we have positive 4x. And we're going to subtract that 10 minus 10 equals 0. And what I would do here is I would check to see, does this factor? Now this, if it factors, will be easier than the other one because the number in front is a 1 rather than a 6. but it still has to actually work. There are some times where it doesn't. So if this factors, that would be x and x. I know that. Now there's different options we have for 10. I'm looking for things that multiply to be a negative 10. And since that number in the front is a 1, it is as simple as saying things that multiply to be a negative 10 and add to be a 4. So things that multiply to be 10. You can even make a little table, guys. I don't know how you guys have shown your work for this in your algebra classes, but if you make like a little table and say, okay, well, 1 times 10, remember this needs to be a negative 10. So it's either negative 1 and a positive 10, or it is 1 and negative 10. We also could do 2 and 5. And those are really the only factors that you could use. So what I'm going to say is pick the one that adds up to be a positive 4. Well, none of those add up to be a positive 4. And with that, that's telling me this is prime. Again, it's that simple to check because the number in the front was a 1. If that number was different, it would be harder. Okay, if I can't factor it, what should be my go-to? And that would be your quadratic formula. I'm going to write that up here, but you will need to have this memorized, okay? It's going to happen hopefully kind of naturally for some of y'all, but if not, you're going to have to make yourself learn it, okay? So this is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're just going to plug the numbers into that where they go. My a is a 1, my b is 4, my c is negative 10. So this would be x equals negative b, so negative 4, plus or minus the square root, b squared minus 4ac, so this is 4 squared minus 4 times a times c. Be careful with your signs, guys. All over 2a. All right, this is negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times 1 times negative 10 is a positive 40, because remember that negative times a negative. And this is all over 2. I'm going to go ahead and keep working on that square, that square root there. This is the square root of 56, which is not a perfect square. However, it will simplify a little bit. So go back to the review where we talked about simplifying square roots. Guys, the square root of 56, you can go off to the side and kind of work on that. The square root of 56 does break into the square root of, what? 4 goes into that, right? 4 goes, I don't remember what it was. Okay, I think it was 4 times 14. Yeah, that would be 4 times 14. Now the square root of 4 comes out, so you get 2 square root 14. And that's what we're going to put into our quadratic formula here. Negative 4 plus or minus 2 square root of 14, all divided by 2. You might be asking, can't we simplify that? Why, yes, you can. But this 2 on the bottom does not divide into the 14. I want to make sure that that is very clear. That 2 does not divide into the 14 because 14 is under a radical and 2 is not. The 2 can divide into both of these other 2 terms, though. So it can divide into that negative 4, turn that into a negative 2, and then divide into this one right up there. Oops. Kind of running out of room there. Okay. And so we get plus or minus the square root of 14. This 2 cancels with that stuff. Okay? And that would be your final answer. Ta-da! Isn't that gorgeous? All right, y'all. We got a little bit left. Okay? So I'm going to go back to my notes here. A few things for you guys. Maybe pause the video and get just continuing in this 1.1. So there's some notes just talking about some terms that are really important. So if k is a real number, that solves an equation where you have f of x equals 0, right? Then all of these things are going to be the same, okay? Where we got these answers just a minute ago, these words, these terms are all used for these values. So first one is that k is a root or a solution to that problem, okay? So again, that's where we got those answers just a minute ago. Those are solutions, or what we call roots. Also, we could call them zeros. That's another term you're going to hear a lot. And then another one is that they are the x-intercepts for that function. And so you'll see that point of whatever that number is that you got, 0. That's the x-coordinate. The y-coordinate would be 0 since it's an x-intercept. All right, we got a problem-solving process here just for you guys to get into your notes. Step 1, understand your problem. Step 2, devise a plan. Step 3, carry out the plan so you solve that model. Step 4, you look back. You want to make sure that you give the answer in context. You want the answer to make sense. So rather than just answering a problem with a number, if it's a word problem, you might want to include writing it in a sentence so that it really makes sense in context. Okay? So we're going to look here at example 3. I would say if you need to write it down, maybe pause the video and do so. Come back when you're ready to work it. So we've got the engineers at an auto manufacturer. They pay students 18 cents per mile plus $50 per day to road test their vehicles. How much did Mallory earn to drive 440 miles in one day? Denzel earned $167 in one day. How far did he drive? So we got 2 little questions here, and we're going to go through each of them. So again, I'm going to pull my notes back up. Now, earlier when I did a problem, some of the marker bled through, so let me see if I can fix that a little bit. Okay, here we are. All right, the first thing I do is I hear this and I'm like, well, there's an equation that I can write to represent this, especially if I'm going to be working problems and trying to calculate things. It might be easier to have an equation that I can reference. And it's really not too complicated on this one, right? They said, just think about the scenario. Okay, I'm going to write a function. We have a function, I'm just going to call f of x. They said engineers at an auto manufacturer pay students 18 cents per mile. Okay, so I'm going to say right here, that is 0.18 per mile. We're going to let x be the miles. Plus, literally put a plus, $50 per day. Okay, now it's important that my money was in the same terms, right? So rather than putting just 18 for 18 cents, this is $0.18. And I made sure that that money matched here because I have $50 over there, okay? Otherwise, that's my function. That's as simple as it is to write. But how about working out our problems? So it says, how much did Mallory earn to drive 440 miles in one day? So remember that x is miles in this case, right? So if Mallory drove 440 miles, the easiest way to set this up is to let x be 440. So I'd have 0.18 times 440 plus 50. Now, this is a time where I'm okay with you getting a calculator because typically when it comes to stuff like this, your AP test is not necessarily going to want you to multiply those decimals in your head. So if you want to go to your handy dandy calculator, go to your calculate screen and you just type it in the way that it is, we would have 0.18 times, I know you can't see that very well, there's a little glare, 0.18 times 440 plus 50, just like that. I'm going to hit here on this calculator. Your enter button is this one on the bottom right. And I got 129.2. So I got right here 129.2 as my answer. Now here's the thing, what I'm meaning with like answer in context, this 129.2 may not be the best way to answer this. Okay, what I could say is Mallory earned $129.20. And that would be okay. You could even write it more. You could say to drive 440 miles. You could even make the sentence a little bit longer. But even this right here, Mallory earned $129.20. That's good enough. All right, part B, they said Denzel earned $167 in one day. Now keep in mind, when your function, this is talking about your dollars. This is talking about your money, how much you earned in one day. Okay? All right, so we're going to just plug in those values where they would go. The 167 in one day, that would go at the beginning of the function. 0.18x, we don't know, right? We're trying to figure out how many miles. X is the miles, plus 50. And you'd solve this for your x. So the next thing we would do is we would subtract the 50 on both sides so that we would have 117 equals 0.18x. And this again is where I'm fine if you want to type that in a calculator. You would end up with 650 equals x. So again, 650 may not be the best answer, but we can say that Denzel drove 650 miles. Okay, there it is. All right, guys, just a couple more notes. I know this video is kind of long, but we're almost there. Just a couple little ideas for that AP test. Some really important things that we have noticed about the way that they want answers on their test. And I think I've mentioned these in class already. However, in case you missed that, here's a couple more things. If you want to get those in your notes, feel free. There's a fun little phrase that a lot of people are using, saying YOLO instead of saying YOLO, right? You only live once. No, this is you only round once. In regards to decimals, guys, if you are supposed to be getting a decimal answer, you only round once, and it should be at the end of the problem to 3 decimal places, okay? That's if you have to round a decimal, if they want a decimal answer, you round it one time at the very end and put it in 3 decimal places. If that's not done, it will be counted wrong, all right? Second thing, if you have already been noticing, I have not been circling or boxing in my answers, and that is simply because sometimes on that free response question on the AP test, you are going to, sometimes it can be in your best interest not to. It's a little safer not to circle those answers. But you still want to make sure that your answer is easy to find and readable. If they can't read it, they can't really grade it. So make your work easy to read. Try to make it clear where your answer is. However, if the correct answer is in a different place on the page and you haven't circled anything, they should still be able to count it correctly. Okay? So just keep all that in mind. We will definitely see more and more things come up, but those are some big takeaways I want us to go ahead and start practicing. If you need a decimal, round at the end to 3 decimal places. And we're going to try not to circle or box our answers as much as possible. Okay? All right, guys, that is it for our very first pre-cal lesson. I hope that that is all good. Guys, check the Canvas page to see what your assignment is. It will have that all listed out, should be nearby this video. So check for your class, see what your assignment is for this, and I will see you guys in the next lesson. All right, bye.